Good day everyone. I am Humilda Rosal Joy from BS Ed Math 2A. So in this video, I will explain how to find the volume of solid revolution using calculus. This video focuses on how to find volume of solids formed by rotating a region around an axis. We'll explore three methods. This method is the disk method, washer method, and the shell method. Each method is used depending on the orientation of the region relative to the axis of rotation. First is the disk or washer method, used when the cross section perpendicular to the axis creates a circle or rings. Shell method, used when slices parallel to the axis of rotation form cylindrical shell. Remember, if elements are perpendicular to the axis of rotation, use disk or washer. If elements are parallel, use shell method. Next, let's proceed to the problem. Find the volume of the solid generated by rotating the region bounded by the curves y is equal to 2 sine x and x axis. So we got the 3D generated. This forms a shape similar to the cake mold. We'll use the shell method because the region is described in terms of x. We're rotating around the y-axis, which is a vertical line. Disk or washer method would require solving for x in terms of y, which is complex due to the sine function. It takes harder or nearly impossible to integrate by hand. Shell method allows integration in terms of x directly and is simpler in this case. So, we are asked to find the volume of the solid formed by rotating the region. Under the curve, y is equal to 2 sine x from x is equal to 0 to x is equal to pi about the y-axis. The shell method is the best choice. So the general formula for the shell method is v is equal to 2 pi integral of radius times height evaluated from a to b. In our case, the radius of the typical shell is the distance first the y-axis, which is the x. The height of the shell is given by the value of the function at that x, which is 2 sine x. So the limit of integration are from x is equal to 0 to x is equal to pi. So the volume becomes v is equal to 2 pi integral of x times 2 sine x evaluated from 0 to pi. So we have, as we can see, it has an integer inside, integral. So we will multiply 2 to 2 pi, so it becomes 4 pi. So 4 pi is integral 4 pi integral of x sine x evaluated from 0 to pi. So in integration by part, we now need to compute integral of x sine x evaluated from 0 to pi. To solve this, we use integration by part, which follows the rule, which is the integral of u dv is equal to uv minus integral of v du. So let u is equal to x. So derivative of x is equal to 1. So we got the du is equal to dx. So dv is equal to sine x, derivative of sine is equal to negative cosine x. So we got v is equal to negative cosine x. So now, let's apply the integration by parts formula. So we have here an integral x sine x is equal to negative cosine x plus integral of cosine x derivative. So simplify we got negative x cosine x plus sine x. Now we plug back into the volume expression. V is equal to 4 pi quantity of negative x cosine x plus sine x. So substitute the limits. So let's evaluate at the upper limit, which is the x is equal to pi. So negative pi cosine pi is equal to negative pi times negative 1 is equal to pi. So we got the sine pi is equal to 0. Next, let's proceed on evaluating the lower limit, which is the x is equal to 0. So 0 times cosine 0 is equal to 0. So we got the sine 0 is equal to 0. So we can put it all together. We got the v is equal to 4 pi quantity of pi plus 0 minus quantity of 0 plus 0 is equal to 4 pi times pi is equal to 4 pi squared. So the final answer, we got the v is equal to 4 pi approximately 39.48 cubic units. So for the conclusion, so the result tells us that the volume of a solid shape like a cake mold formed by rotating the curve is approximately 39.48 units. That's all. Thank you.